Hi students, welcome to our science review today, and to complete this session we are going to talk about the ionic charges and balancing chemical compounds. In here we need to identify ionic charges of the elements, and second we have to balance the chemical compounds. So look at the difference between atoms, molecules, and compounds. Since we are now focusing on compound, a compound consists of two or more elements and they are chemically bonded in a fixed ratio. And examples of compounds are the following. So we have the water. It has one atom of oxygen and two atoms of hydrogen. In the sodium chloride, there is one atom of sodium chemically bonded to a chlorine, or one atom of chlorine. And while in ammonia, we have one atom of nitrogen chemically bonded with four atoms of hydrogen. So those are examples of compound. Remember that we have two types of compound. Number one is the covalent compounds. And based on its composition, there are two or more non-metallic elements sharing valence electrons. Like what you see here, they are just sharing their valence electrons. While the ionic compounds, the composition is that it composed of metal or polyatomic cation that donates electrons to a non-metal or polyatomic ion, like what we discussed before this. Like the sodium fluoride, wherein this sodium donates electrons to a non-metal, and that is fluorine. That is an example of ionic compound. So in everyday life, you will encounter some or various ionic compounds, such as the table salt or sodium chloride, NaCl, sodium bicarbonate, or known as the baking soda, or NaHCl3, the train cleaner dye, which is the sodium hydroxide, NaOH, Epsom salt, or magnesium sulfate, MgSO4, sodium hypochlorite, or the bleach, the NaOCl. So let's move on to really what we need to know or to be familiar with, and that is ionic compound. In writing down chemical formulas of ionic compound, always remember that it is a kind of formula that shows the kind and numbers of atoms in the smallest representative unit of the substance. Again, it shows the kind and the numbers of atoms in the smallest representative unit of the substance. Example: the NaCl, the NaF, sodium chloride, sodium fluoride, we have the calcium oxide, potassium oxide, magnesium chloride, magnesium nitride, and potassium nitride. These are ionic compounds. And looking at their composition, you will see that a color red signifies a metal and a blue is a non-metal. So right then, we can apply that in terms of ionic compound. There is really a chemical bond between metal and non-metal elements. How are we going to write ionic compounds formula? We have to follow the instruction or step-by-step procedure. Example: zinc hydroxide. So first, you have to write the symbols for the cation and the anion, including their charges. Example: for the zinc hydroxide, zinc and then hydroxide, the symbol for zinc is Zn, and hydroxide as one compound already is written on OH. Then you have to get their charges. How are we going to get the ionic charges? You may look at your table of elements and find the charges of zinc and hydroxide. So I got here the zinc, +2, and For the hydroxide, we have +1 for hydrogen and -2 for oxygen. So getting the difference between the two, you will get this: zinc +2 and hydroxide -1. So -1 is 1. Next, check if the charges are balanced. So in this case, +2, -1 are not considered balanced. So if this is the case, we really need to balance the charges. That's step number 3. If necessary, using subscripts, you have to use also parentheses if you need more than one of a polyatomic ion, OH is a polyatomic ion. And you have to do the crisscross method to balance the subscripts. So let's balance it now. So zinc will be a +1 since we do the crisscross method, and the OH or hydroxide will turn into 2. So you have to change this -1 into a +1 when you crisscross it. So writing it down, Cn, and then open close parentheses for the OH with 2. If the charge is already 1, then you don't have to write it down on the subscript followed after the zinc. You don't have to do that. It's automatic. So how are we going to get the ionic charges in sodium bromide as the second example? Again, first you have to write down the chemical symbol of the elements. Sodium Na and bromide is Br. The first letter of the chemical symbol is written in a capital letter, while the second one is always a small letter. Next, so sodium is an alkali and bromide is a halogen. Next is you have to balance it, right? So get the ionic charges. Like in sodium, it's +1, and in bromide, it's -1. So as you can see, both of them are 1, so they are the same considering their charges. If that will be the case, if they are balanced, then you just need to write down the chemical formula like this, NaBr. You don't have to place the subscript anymore since they are already balanced. Another example is the calcium sulfide. So in the calcium sulfide, first step, you have to write down the symbol. Calcium is Ca, sulfide or sulfur is S. Calcium is an alkaline earth and a sulfur is a nonmetal. Next, you have to write down the charges, a +2 and a -2 for sulfur. Crisscross method, but since they are the same, you don't need to crisscross them anymore. So in here, you just need to write down calcium sulfide like this. So there you go. That is our review for today. Hope you learned something and hope to see you again soon. Bye bye.